In this experiment, we have a 3/8 by 1 inch by 8 inch piece of pine that we set up as a cantilever beam. Our dial gauge is set 6.5 inches away from our cantilever point, and we are going to be placing 3 amounts of weight on the end as a point load to see how much our beam deflects. And for our first load, we have 90 grams as our weight. I'll put it on there, on the end of it.
The deflection is 59 thousandths of an inch.
For our second load, we have another weight. It's going to be a total of 180 grams. Put it on the same spot.
The deflection is 110 thousandths of an inch.
For our next amount of weight, it's the same, another 90. Be 270 grams. Same spot.
The deflection is 215 thousandths of an inch. In this experiment, we have a couple of uncontrollable variables, such as our setup isn't exactly what it could be, being that this rod is circular, trying to go up against a flat surface could cause the angle of the dial gauge to be wrong. The dial gauge could be miscalibrated, or something could be wrong on the inside of it because it doesn't always go back to zero even when there's no load added to it. The wood that we use doesn't go back to its original shape. Once the loads are taken off, there's about 10 thousandths of a deformation still left.
To draw some conclusions from this experiment, we learned that pine wood in this kind of setup, being a cantilever 6 inches away from the dial gauge, that each additional weight we add, each 90 grams added, it deforms the beam more and more in each case. So to draw a conclusion, the pine wood's not very resilient. It won't go back to its original state every time because the buildup of deformation it's getting. And if we turn the beam in the upright position like a truss, the beam would be able to withstand a more heavier point load. However, it could still deform just because it's wood. And applying this to a real-world application, wood's not really used as a cantilever. And when it is used as a cantilever, it's on short, small applications like the overhang on a roof, where it's just really small and it's not really taking a large amount of load because it can't withstand that much. And usually in a large cantilever support system, some kind of steel or larger support system is used to withstand a larger load, because from what we can draw from this, the piece of wood can't withstand a large load on its end, or at least in this situation on the end, because the wood deforms and doesn't return to its original shape like a normal material.